Okay, so for this problem, it is how many different combinations that $5 bills and $2 bills can make a $7. So we say we have, let's say we have X $5 and Y $2 bill. So X $5, then we have 5X plus 2Y equals 17. So the question is how many solutions? Question we want to find the number of solutions. So this is the integer equation. Okay. So this X, so the conditions are those X and Y at least cannot be negative, should be at can be 0, could be 0, but let's say so let's check X. Can X be 0? So we say no, right? If X equals 0, then 2Y equals 17, so X cannot be 0. So what is the possible value for X? X can be, so we just check 1, 2, 3, 4. So if X equals 4, 4 times 5 becomes 20, so cannot be 4. So X can be only 1, 2, 3. So we just check if X equals 1, what is the Y value? Can we have this solution? We find Y X equals 1, then Y equals 6. So if X equals 2, then 2Y equals 7. So no such Y. So if X equals 3, then we have Y equals 1, right? Okay, so actually we just have these two combinations, two solutions. Okay, so this is like in a math contest with 10 problems. We have 10 problems. So you can get 5 points for correct answer and lose 2 points, so negative 2 points for an incorrect answer. So Olivia, she answered every problem and her score was 29. So we have we have 10 problems, but we don't know how many problems she answered correctly. So suppose we say correctly answer X problem, then not correctly should be 10 minus X, right? Okay. So how many points? So we say correctly 5 points, but not correctly need minus 2. So okay, so this is total score. So her score is 29. So we just want to solve for X. So such a problem, so easy, right? So just one variable linear equation. Okay, so for this problem, it says Mikey has some oranges and some pears. So he uses her juice to actual 8 ounces of pear juice from 3 pear. So let's say the 3 pear get 8 ounce of this pear juice, and 8 ounces of orange juice from 2 oranges. So 2 oranges also get a ounce. Okay. So she make a pear and orange juice blend from an equal number of pear and orange. So we don't know the equal number. So we just put an equal number. So let's say, suppose she has 6 pears and 6 oranges. Okay, so from 6 she can make 16, right? So it's juice. And from here 6 oranges she can make 24, right? 3 multiply 8, yeah, 24. Okay, so put it together, she can make the total, so this equal 40, right? Okay, so the percentage for pear is 16 over 40. So you can easily convert it to percentage. Okay, so let's say we say these 4 people, L, M, N, O, they are good friends. And for money, so we say for money, O has 0 money. We put a 0. So suppose like this has, we just put the L money or M, N. So here's 0. So this is not O, 0. Okay. Okay. So let's say, so this guy M give O 1/5 of his money. Okay. So we can say by now he left 4 over 5. 4, 5. Oh, no. 4, 5 here. Then by now O has so many money. So 1 over 4. 1 over 5. Yeah. So out has so many money. Okay. And L give 1/4. So L gives 1/4. So 1 over 4 L. So here has 3 over 4. 3 over 4 L. Okay. And N give 1/3. So she has 2 over 3. 2 thirds A. And here 1 over 3A. Right? Okay. So this is the information so far. So now let's say each give out the same amount of money. Okay, so we know these 3 numbers equal. So suppose this is, so we have this, like we have 1 over 5M and 1 over 4L and 1 over 3A. Those are same. So we put this as a K. Okay. So by now we say O has 3K. The money has 3K. So we want to find what fractional part of the group money does alt now have. So alt has 3K. So totally money is L plus M plus N, right? So totally how many money? So we say L equal 4K and M is 5K and N is 3K. So this is percentage of fractional part. So we can cancel K, we get this equal 3 over 12, right? Okay. Okay, so just 6 trees are equally spaced along one side of straight road. So let's say like here we have 1, 2, 3, 4, 5, 6. We have 6 trees. So the distance from the first tree to the fourth tree is 60 feet. So from here to here is 60 feet. So we know each distance is 20 feet. Okay, so we can easily find what is distance between first one and last one. So last one, so here we have, so just 20, so multiply 5. We have 5 intervals. Okay, Homer began peeling a pile of 44 potatoes. So here's 44. So the speed is 3 potato per 1 minute. Okay, so 4 minutes late, Christian, this guy joined him and peeled at this rate, 5 potatoes per minute. So here, the 4 minutes late. So by now, let's say, so we just start from here. 4 minutes late, then about has appeared how many? So 1 minute 3, so 4 minutes 4 times 3. Okay, so now so many left, right? So we have, let's say, 44 minus 12 equals 32. So by now, actually, we have 32 potatoes need be paired. So by now, they're both of the two guys do the job together. So he can 14 minutes, so he can put 3t plus this guy can 5t, so we let this equal 32. So we find t equal 4. So after, so they just need 4 minutes. So when they finish, how many potatoes had? Okay, so question: how many potatoes had Christine peeled? So the times he peeled 4 minutes, and speed is 1 minute is 5. So Christine peeled 20, right? Okay. So at the beginning, the tank is 1 over A for only so much gas. So he purchased 7.5 gasoline for $10. So with the additional gasoline, he's so by now, let's say, so 1/8, then added 7.5. So by now, here become 5/84. Okay, so we want to find the number of gallons of gasoline his tank can hold. So we let this number as x. So we just check, let's say, so here let's say, so we have this equation. This part is 1/8 of x plus 7.5, which become 5/8x, right? Okay, so from here we can easily solve for x. Just multiply 8, so x plus 7.5 multiply 8 equal 5x. Okay, so move the 5x to here, so 7.5 multiply 8 equal 4x. Okay, so we can find x can just equal 7.5 multiply 2, right? So that's equal 15. So this problem say the manager plan to distribute a $50 bonus to each employee. So give each body $50. But if give everyone $50, he has no enough money. The fund contain $5 less than what he needed. Okay, so here we don't know the number of employees, how many people. And we also don't know how much money how much money the fund, how much money he has. Okay, so then for this first sentence, we can convert the first sentence into an equation. So equations give x each one $50, then x people should have 50x. This money should equal total y plus 5, right? So y is not enough, so you need $5 more. Okay. Then so if give everybody 45, so here is 45x. If we give everybody $45, then the money is the y is big enough. So this y still can keep $95 can keep it. So this equal y. So y is too much. So this equal y minus 95, right? So we have this equations. So 50, if give everybody $50, then y is not big enough, need a plus 5, right? If give everybody 45, then y is big enough, so y can minus 95, right? Okay, So what is the question? Question, the amount we want to find amount of money we want to find the fund, or we want to find y. So here question to find y, not x. We want to find y. Okay. So for such a problem, we say we just can cancel x, then find y. But for this problem, maybe cancel y, find x first. Find x really easy. So we say like this equation minus this equation 1 minus equation 2. So we can easily find 5x equal 100. So x equal 20. Okay. So then we can find y equal. So y equal, let's say, y equal, so 50 multiplied 20 is 1000. So y equal 995. Okay, so the 5 tires of a car, like a 4 loaded tire and 1 spare tire, were loaded so that each tire was used the same number of miles during the first 30,000 miles. The question: how many miles was each tire used? So the first, maybe you can say, oh, total mile is this thing divided by 5 tires. But this is totally wrong, because when the car, let's say when car travel so many miles, we need 4 tires. So for tires should be like a travel this multiply 4, then divided by 5. So we have 5 tires. Okay, yeah. Okay. So there's a problem. The distance between 5th and 26th exit on an interstate highway is 118 miles. So here 118 miles. So this is 5th, then 6th, like that, right? So here is 126. Okay. If any 2 exits are at least 5 miles apart, then what is the largest number of miles there can be between 2 consecutive exits? That between. So here with the largest. So largest, so means we let others as the smallest. Then we can leave 1 for largest. So we just check it out here, just the 5, each is 5, 5, 5, 5, 5. Then this 1 is the largest. So we say like here, so 5, 5, 5. So from here 5, 5. How many? From 5 to 25. So this is that we have 20 intervals. So this is 20 multiplied 5 plus this x equal 118. So we find this equal 18. Okay. So for this problem, 1/2 of water is poured out of a full container. Then 1/3 of remain is poured out. Continue the process. Okay. So this means like okay, first time, let's say first time goes 1 out. So by now this. So second time, no. Yeah, first time 1/2 is poured out. Then 1/3 of remained. So here is 1/2. Then this 1/2 1/3. So this actually is 1/2 times 1/3. This is poured out. So how much left? So left is this actually is let's say equal 1/6 is poured out, right? So then second time by now, let's say we just say left, we just check left. Okay. First one is 1/2. Second one, then left left let's say 1 minus 1/6 is 5/6. No, 5/6. No. Let's say first one 1/2. Second one remaining 1/3. So remaining 1/3 this. Then how much left? It should be 1/2 minus poured out. Poured out is 1/. Poured out, this is poured out. So this equal 1/2 minus 1/6. So this equal 6 1/3, right? Okay. Okay. So then 1/4 of remained is poured out. Then okay. So by now we have 1/3 left. Minus 1/3 multiply 1/4 like this. So equal what? We can take 1/3 outside. This is 1 minus 1/3, 1/4. So we found out 1/4. Okay, so we find the way. So after the first time, 1/2. Second time, 1/3. Then let's see. After how many pouring does exact 1/10 of the original water remaining? So 1/10 means after number 9, after 9th pouring out, right? Okay, so we just almost have a half hour, so we stop here.